Welcome, everybody, to today's webinar. We're going to be talking about how to easily add zero trust mobile bot protection to the app security that might already be in place and how easy that might be and why it's necessary. Uh, just to kick off a quick introduction for myself, then I'll hand it back to you, George. So my name is Pierce. I'm the VP of API and Mobile AppSec here at Approved Mobile Security. I'm calling in from New York today. I've been in the mobile app security space now for 8 or 9 years. Started off the earlier part of my career focusing heavily on app hardening. Graduated up to be considered a subject matter expert on obfuscation and white box cryptography. That experience gave me the opportunity to speak to some of the smartest security architects in varying industries like banking, automotive, medical device, even smart home and IoT kind of use cases. And these architects were looking to solve very, very tricky problems in untrusted environments they didn't have much control over. But one problem kept popping up: how to secure APIs intended to speak only with authenticated versions of their apps. At the same time, I also saw that hackers, both white hat, black hat, gray hat, kind of shifting away from focusing on attacking the mobile app only and trying to use APIs as their entry point. So I was very happy to learn about Approve and transition over here to tackle this problem about 2 years ago.
That's great, Pierce. So my background, I'm George McGregor. I'm based in the Bay Area in San Francisco. And I joined Approve about 4 years ago. I'm leading the marketing activity. And before Approve, I worked for application security vendors like Citrix, Netscaler, and Imperva. And so was responsible for their application portfolio there. And actually, I submitted for both companies the WAF Magic Quadrant submission for Gartner. So got very deep into that kind of back-end application security world. And as part of that, recognized this issue or gap with mobile app security. And that's why I joined Approve, to be part of the solution, if you like, to solve that issue. So I'll use some of that background during this presentation as well as we talk about backend AppSec. So maybe what we should do is just talk a little bit about what we want to present today.
Yeah, that's a good idea, George. Before I jump into that, I forgot to mention if there's any questions, we do have a Q&A panel on the bottom. That's usually a better way for us to answer them towards the end of the meeting than in the chat itself. So any questions as we go through this, please do enter them in the Q&A button. You should see that on the bottom of your screen. Today's presentation will be addressing basically the shortcomings of backend security from many of the large vendors in the space today, but more importantly, why this approach can never really effectively deal with the threat of mobile bots, cloned apps, hacked devices. We're going to be talking about, more importantly, a way forward, how to combine this back-end security approach with comprehensive mobile protection. And, at the end, we'll put it all together and hopefully give everyone a clearer picture on what they can do to effectively combat this tricky problem.
Okay.
Next slide.
Yeah, so let's start by looking at the adoption of APIs and API security and a little bit of a timeline here. This chart shows API adoption in terms of internet traffic. And we got this from, compiling data from Akamai, Gartner, and others. And most assessments tell us that, internet traffic is now made up of 80% of API traffic. So, the protection of APIs has evolved over time. We'll talk a little bit about WAFs and their history. But, since they were deployed, this API traffic and the amount of traffic has been growing. And we've seen large AppSec vendors investing in bot mitigation, API protection and discovery, and more. They're trying to build a more comprehensive integrated web app and API security. And then really right now we're seeing this renewed focus on the mobile side. So what we described here as mobile first focus, looking at mobile RASP and multi-channel API security. So, this is a pretty important kind of evolution. It's really all about APIs now, and it's increasingly all about mobile. Now, you already certainly have a WAF in place and back-end application security. And so, WAFs originated in the early 2000s, Web Application Firewall, and their job is to inspect HTTPS traffic and enforce rules to protect applications. And mainly they're aimed at blocking injection attacks and known vulnerabilities, cross-site scripting, this kind of thing, and enforce rate limiting, and really enforce schemas in and make sure that the messages that are coming to the back end are well formed. It's a little bit like a reverse proxy and a rules engine. Applications are now API first, especially mobile and IoT. And so the WAF is evolving and, it's starting to use machine learning and integration with bot management and the like. So we've seen the big vendors, application security vendors, focus on improving and increasing the focus they have on some of the new threats. And there's been a flurry of purchases. So, F5 bought Volterra for API security and a bot vendor Shape. Akamai has been purchasing small companies in the API security space. Imperva bought RASP vendors and bots and API security. And there are still some standalone API security and bot vendors out there. Examples like Salt Security, for example, that focus on API discovery. So in principle, most of these big app security vendors now present that vision. I should say Gartner evolved their view of a web application firewall to add API protection as well. And they're really trying to present that vision of a kind of multifaceted approach to application security. But the trouble is, it's all based on inspecting the traffic coming to the back end. And they're very complex and increasingly difficult to manage. And there's a lot of ambiguity there and a lot of false positives. And they really are just, as we'll see, are not effective at all at the issue of addressing mobile bots and mobile threats. So if we take a look at that, Pierce, you want to talk about the mobile issue?
Yeah, so with all the design and investment effort focusing on APIs, web apps, something was missed on the mobile side. But as we can see now, looking at this graph, the blue line talking about mobile originating API traffic, that traffic well exceeds above 50% of the internet traffic. So it's a pressing issue. Legacy solutions don't really, they weren't designed, it's not in their DNA to prevent this kind of risk to APIs. So that leads us to the real issue at hand, a faulty premise that all threats can be observed, managed, and blocked from observing the requests and traffic arriving at the backend APIs or servers. What we'll argue is even with the most sophisticated AI and machine learning analysis, this premise is wrong and just doesn't work for mobile apps and the devices they run on. So, customers are starting to understand this risk. They're requesting enhanced protection against mobile originating threats. And the realization is that mobile apps, they're in an environment outside of the control of an enterprise. So it's very difficult to build trust within traffic originating from mobile apps. They're easily decompiled, easily modified. Even the environments they're running in can be hacked. A multitude of runtime threats. I mean, the list goes on. But it comes down to this. Attackers can easily generate traffic that mimics the behavior of a mobile app simply by sending HTTP requests that are similar to those sent by authentic applications. Attackers might even log in as a valid registered user in some cases. They might perform automated tasks such as content scraping and other web attacks from this attached HTTP client tool. So the fact of the matter is, without an eye on the device, without some more context coming from the device, backend AppSec won't be able to do an effective job of distinguishing between genuine apps or fake apps and scripts. And there's also the problem that mobile app security, well, I'll get to that in a later slide, but let's talk a little bit about some of the real world threats that we've seen take place, starting with Kahoot. I might be saying that wrong, George, so correct me if I'm wrong. But basically what happened here was it was an educational quiz-based kind of gaming app. Attackers reverse engineered the mobile app to mimic legitimate client behavior, and then they would flood these quiz sessions with bots. The issue was that the app's API requests weren't verified against genuine app instances in this case. So the impact was basically there was a flood of thousands of fake players joining sessions, rendering quizzes unusable. An SDK could have fixed this problem through app attestation, which would have prevented bots and repackaged apps from generating, in the case of our solution, valid tokens, but basically from accessing the backend services. Another example, in 2020, Starbucks experienced massive gift card fraud via API abuse. Basically, attackers reverse engineered the Starbucks app and automated fraudulent transfers between gift card balances. The API issue here was that there was no client-side integrity checks, and requests could be replayed and manipulated, causing massive fraud at scale and stolen funds using script automation. An SDK-based AppSec solution would have had runtime checks, would have blocked unauthorized scripts or tampered clients. Another example that I've used in the past is in 2021, T-Mobile experienced some SIM swapping tool abuse. Basically, mobile app endpoints were used to validate phone numbers, which were then linked to phishing and SIM swapping operations. In this case, the APIs accepted requests from modified or unauthorized app instances, and the impact was basically unauthorized number porting and identity theft. Simply having an SDK in place that could verify that only untampered apps and safe environments could connect, these endpoints would have been protected. The list goes on and on, George. We have examples from like TikTok, British Airways, Snapchat, but I don't want to use up all of our time here on this slide, so I will move on. But I think the moral of the story is it's industry agnostic. If you have APIs, if you have a mobile app, and you have something valuable, attackers are going to try to get their hands on it.
They'll find a way, yeah.
So I think I was talking a little bit about, we were talking earlier about like back-end security. I think it makes sense to talk about mobile app security and how that has evolved over time. Of course, mobile app developers, they care about this. It's a problem they have to solve. But there's been some disjointment, if you will, in the approach that you can take to secure your mobile app and the back end cohesively together. So the traditional approach to mobile app security has been what's called in-app hardening, things like code obfuscation, on-device RASP. These are some techniques you might have heard of as a mobile app developer that maybe would be a little bit more foreign to API security experts. But basically, this is an approach to sort of camouflage things, using obfuscation to make things more difficult to find. I've already seen AI play an instrumental role in limiting the effectiveness of obfuscation. What used to take days, hours, now can be deobfuscated in a matter of minutes. On-device RASP, very effective at preventing tampering in the moment. But over time, again, because this is an untrusted environment and all of those security decisions are being made on the device, a sophisticated hacker will be able to manipulate them to get them to say things they want them to say. Um, there's also been investment in pre-deployment testing, things like SAST, DAST, MAST. Those don't really address runtime manipulation of devices and apps. So basically, from the point of a developer, investing in the traditional mobile app security solutions, that will help harden your app. But the fact of the matter is you don't even need to use a protected app to access these APIs. So it doesn't really work cohesively with the whole story.
Mhm.
So what's really needed is mobile runtime protection integrated with backend security, and that's what we're going to be talking about in the next couple slides. But first, let's take a look at mobile runtime contextual information, how that can be gathered and how that can be used. Um, okay, so this is where maybe my old life of RAS obfuscation, white box might influence my bias a little bit. But basically, I had mentioned this already. When an attacker has unfettered access to an app and the device and the security that that app and device are running on, they can do things that most of us probably haven't even thought of to gain greater access and privileges or manipulate the on-device security techniques. Therefore, by the time anything gets from that app to the cloud, it's already too late. It can't be trusted. So back-end security tools, I do want to mention they're powerful, but in this context, they would be blind. Inspecting traffic at the edge, analyzing headers, behaviors, rates, known attack patterns, blocking SQL injections, implementing basic credential stuffing, prevention. This is all effective to a point, but without without more context, it's difficult to tell if any of this information being used to make security decisions can be trusted in the first place. So they're basically operating from a position of limited visibility. They're assuming the client making the request is legitimate. The request wasn't forged, automated, or made from a tampered app or emulator. Without being able to see what's happening on the actual device, they're basically blind. So in order to reliably counter these threats from your mobile application, it's good to use a mobile SDK that's sending more context to something external of the app to make security decisions. This can provide continuous verification of contextual information from the app and the client environment. And really, the only way I've seen to effectively get this information is with some kind of SDK embedded in the mobile app.
Right. Okay, so we've decided we need this eye on the device. And so it's worth taking a look at the two broad areas where, this or the techniques that are being used to do this. So, there are really two ways of going about this. One is trying to look at user behavior signals, which has got a long history in the browser space. And the second is looking at software and device identity signals. So, let's take a quick look at those two things. So the behavior signals, this is something that the traditional app security vendors are very comfortable with because it's the kind of thing that they've been trying to apply to web-based, browser-based techniques. So the idea is, of course, that it tracks key clicks and tries to distinguish from, bot behavior from real humans. Of course, that's increasingly difficult as bots become more and more sophisticated and try to replicate human behavior. So, this can be very hard, and the processing and analyzing of large volumes of the behavioral data in real time needs significant computational resources, and that can impact the system performance. When you're looking at this, you need to worry about the challenges and limitations it's really important to look at the richness of the behavior signals and and how they're collected. And this can be difficult because vendors tend not to give details about what's captured, and machine learning is pretty much obscured by its very nature. So the biggest issue is frequent false positives and negatives that you have to manage. So, you need to have a team that's on constantly looking at this, because what you don't want is, genuine customers disrupted by your security posture. And any approach to presenting user challenges should be really carefully evaluated because of user experience. We all know and hate capture. And we know of the impact that has on customer experience. So software identity signals are really a better way. They offer some advantages in terms of accuracy, and in general provide a more deterministic approach. And what they're doing is they're looking for problematic software or configurations on a device, giving clear indications of bot activity. So device and app fingerprinting can effectively recognize automation attempts. And this is pretty important. So, how do you evaluate this? Well, the absolutely key thing is platform coverage. So it's not just about knowing if a phone is, rooted or if the operating system is being tampered with. You need to be able to look at dozens of things that could be going wrong in the environment. You have to do that at runtime. And then another really important piece is, you need to check, you need to be able to distinguish legitimate users who have uncommon software configurations. So, for example, gamers, right, where maybe they've rooted the phone or something like that. You don't want them incorrectly flagged as bots. So it's very important that there's a kind of granular way of managing the policy in real time, so that the checks can address different use cases and threats. So that's going to be a very important aspect of this as well. But in general, this provides a better way forward to getting that contextual information about what's going on in the mobile device, and of course, doing the app attestation. So let's take a look at what mobile attestation should look like, and then that will, with that, we'll understand how we can integrate this with any backend app security in a very effective way. So we're using Approve as an example here, and this is how Approve works. So first thing, of course, is you register a new app before you put it into the App Store, and there's a fingerprint taken of that app release and stored in the Approved Cloud service. And then once you've deployed the app and the app is in millions of mobile phones, then the runtime verification process works. So when an API call is made by the app and there's no token available, the integrity assessment process starts. That's step 2 here. And it's looking at the app to verify that it's genuine, and it's looking at the device and running these, dozens of checks to look for something suspicious. This is initiated automatically, and the Approve SDK verifies the environment. And then it sends information back to the cloud service. So this is a very critical piece. The validation is not actually on the device and can't be tampered with. And in the cloud service, there's analysis on the data that's coming back, and a decision is made based on security criteria that you've set for your account. And these policies are dynamic and can be updated. If the criteria are met, then the Approved Cloud service provides a token back to the SDK and back to the app, and that's automatically inserted into the request going back to the backend system. So that the token is short-lived and it's signed, and the mobile app doesn't know anything about whether it's valid or not. It just integrates that token and sends it in the request. So it's added automatically to the header, And obviously the back end is then responsible for checking that and seeing if the request should be fulfilled or not. Pinning of the connections is automatic, and so there's no way anything can be intercepted by a man-in-the-middle attack. So this approach provides a positive authentication model for mobile apps and devices, and locks out bots and threats.
One thing I'd like to add, George, is
Yeah,
it assumes the mobile app and the device are untrusted until a successful attestation. So the assumption is this device can't be trusted until we've proven that it can be,
yeah,
and only the good traffic will be able to communicate with the back end in that case.
yeah.
But a true zero trust approach.
Yes, absolutely. Every single request is validated. So approve is always accurate and deterministic, and it can be adjusted via the policies in runtime. So, there's no false positives to manage. And as we will see, the critical piece here is it's a standard JWT token that's included in every request. Now, once you've got this kind of attestation in place, that gives you an opportunity to manage access to secrets and API keys. And so we should maybe take a quick look at that as well, Pierce, if you want to just talk about that.
Yep, let me just get myself off mute here. So I had mentioned I had worked on some white box cryptography deployments in a past life. One of the key things we were trying to do was basically make sure secrets weren't accessible, using a way of hiding them on the device using technology called white box cryptography. Now, the secrets were still on the device, but they were hidden and very difficult to access. Uh, every year, there would be different kinds of sort of competitions, if you will, to determine what the best white box in the world is. And they do a good job, but at the end of the competition, they've always been broken after a certain period of time. So we can safely say, given that secrets living in an untrusted environment are constantly under attack, uh, and if there's a dedicated attacker, even with some of the best security solutions on that device, it's a safe assumption that they will be breached. So what's important is to have some kind of way of removing these secrets and safely deploying them just in time of being used, and more importantly, being able to rotate them dynamically should they get compromised. So that's where this feature that I'm going to talk about called runtime secrets can come into play. Basically, it's known that you shouldn't hard code API keys in your app. Your developers are constantly told this, and yet they're not really given a good way of satisfying that requirement. One way to do that would be through the same kind of attestation flow that George had walked through earlier. But basically, you would store API keys or secrets in a cloud, in this case, the approved cloud. You would run an attestation, you would verify that the device and the app can be trusted, and then and only then would you deliver an API key just in time of being used, only after the app and the environment are validated as safe. Um, so at last, there is a solution for this OWASP requirement of not having secrets hard coded in your app.
Right. And then, in fact, if you look on the approved website, you can see there's plenty of stuff about how you integrate with the secrets vault, for example, and how you make this really work end to end. Okay. So let's see if we can bring it all together and talk a little bit about how you actually do the integration with your backend security of choice. So the good news is it's really straightforward, and you can combine this mobile contextual information with any AppSec that you've got in place. And so this is because it's a standard JWT token, which is included in every request. Most customers, as we mentioned, have a cloud service or a WAF in front of the application servers, and then all or most of them support the decoding and use of JWT tokens. So, that standardized, simplified approach makes it very straightforward. And just by means of illustrating this, we picked a couple of examples. We've got Cloudflare, Akamai, F5. And I'm going to touch on this, but I should say also that we have, detailed articles with scripts and everything on our website that you can take a look at. And this works for, as I said, any, AppSec solution. So let's take a look at Cloudflare first. So this is the integration with Cloudflare API Shield, and it's particularly easy because of inbuilt JWT management in API Shield. On the left-hand side, we add the configuration, which is effectively adding the JWT secret to API Shield. And then on the right side, we select the endpoints to be protected and whether we want to block or log non-validated requests. And once you've done these steps, Cloudflare API Shield is now using approve to validate every request. So you can inject that best-in-class mobile security into your app security if you are using Cloudflare already. All you need to do is put in place the SDK in your mobile app, and then you can start checking tokens. Let's take a look at Akamai. It's not quite so straightforward as with Cloudflare because they don't have the native JWT checking in Kona, for example. So you need to deploy something like Edge Worker and write a simple script to parse and validate the JWT. And that script checks the claims that are included in the JWT, which give all sorts of information about what the issue is. And it can check, device and app integrity directly at the edge. If it's valid, then you can forward it to Kona or your edge server. And if it's invalid, you can respond with a 403, or you can do much more fine-grained activity too and respond based on the information that you have about, it's completely flexible. You can manage that in any way you want. So Kona Site Defender continues to apply layer 7 protections to the traffic, but the traffic has been vetted already by this edge worker script, which makes sure that the mobile application traffic is valid and verified. So that's the way you do it with Akamai. And then the final example is F5. Now, F5 have they've got a portfolio of application security solutions. So kind of depends on which one you're using. If you're using the big IP WAF, then you would write an iRules script to parse the JWT and check, send it to a Node.js plugin, and then you can do cryptographic checks and some custom processing on it. You verify the signature and the expiration, and then you drop the request if it's invalid or risky. And if you use Nginx Plus, then that is back. It's like the Cloudflare example. It's very straightforward because you can use the inbuilt JWT validation. So again, this is just, we're going over this at a high level. More information available. We can talk you through how to do this. We can help you do it with any application security solution. And also, of course, you can implement this in a way where you have it in non-blocking mode initially, so you can see what's going on, and then turn it on. And then you're managing all of the traffic coming from your mobile devices and apps. So that is the example. We just wanted to give you a feel for how easy it is. We're here to help. So, if you have a particular use case, we'd love to talk to you about that. So we're coming to the end here. I think, we're going to maybe just bring this together now, Piers.
Yeah. Thank you, George. I just got an interesting question here as well. So I was reading that, which I'll try to touch on in a bit, but it might take a little bit more of unpacking. But before I get to that, so in conclusion here, basically, combining the two approaches we covered can be very effective and easy to do. You can actually easily build defenses that continue to use the backend app security likely you have already in place and inject best-in-class mobile protection. The mobile app visibility and protection provided by something like Approved complements the detection methods already deployed in these backend app security solutions, effectively closing the door to mobile-based attacks, providing a reliable way to stop, in often cases, mobile bot traffic, but other forms of attacks. Organizations can deploy WAFs or API protection for web protection and mobile SDK for mobile apps independently or in tandem. So this offers more of a modular approach that can adapt to changing traffic patterns and threat landscapes. They can be deployed in a phased approach, maybe starting by just monitoring traffic at first and then applying protections. And then backend AppSec gives web bot protection and behavioral detection, while mobile SDK gives app and device visibility and attestation to ensure that bots can't simply shift from web to mobile APIs. I guess I first wanted to thank everyone. Thank you, George, for joining me. Thanks everyone for listening. Any questions? We have email addresses here. I think we do have some time to address these questions. I don't have a clock in front of me, but
Yeah.
yeah, it looks like there's some time here. So I'll start off, George, kind of highlighting one of these questions. I won't give away any characteristics, but basically we have one question that from someone experiencing a lot of bot traffic. They're excellent at faking requests, even with existing bot management solutions. How does Approve generate JWT tokens locally in a secure way that these actors are not able to copy and use them to send bad requests again? So this is it sounds like a very specific scenario. I think there's a lot that Approve does that take the defense in depth approach. One thing we do is basically something called app signing to ensure that a request is coming from a particular instance of an app and a device. So while that means it still might be possible to steal the token, it can't be used in a relay or in an automated attack going forward. There's other techniques we use. The token itself is encrypted. The SDK in the mobile app is obfuscated, and there are ways that we can ensure that the SDK can't just be ripped out of the app. Whoever asked this question, I hope I answered it, but I'm happy to elaborate. If you want to take down my email address, give me a little bit more details. I can give you the specifics, but the moral of the story is that it's an ongoing attack by bad actors. We have a dynamic way to address these, and we're coming up with new solutions that can be deployed dynamically to address specific threats depending on the attacks that the techniques these attackers are using.
Yeah, I think it's important to say that the JWT is generated by the approved cloud service and then delivered to the application. So, it's not locally created. There's no way you could create them or manipulate them on the device. So that's another important point, I think, that the decision is made off platform. Okay. There's another question here, which is how easy is it to integrate the SDK in a mobile app? So the answer, of course, is it's very easy. It's a very lightweight SDK. And what we do is we have quick starts for all of the major native and cross-platform solutions or frameworks. So Android, iOS, React Native, Flutter, Xamarin, Cordova, etc. And basically that helps you, with the process of putting the SDK in place in your mobile app. And then a lot of the sort of updates, etc., are to the cloud service. And as we said, the SDK is really in place for collecting information and sending that to the service. So that's, one thing that's really critical here is you don't need to update the SDK to update the service or to change the policy or to change the secrets or API keys. One thing we've seen in other solutions is this, every time you need to change something, you need to recompile and redistribute the application, which of course is, totally unacceptable. So anyway, hope that covers that. Again, if any other follow-on questions, don't hesitate to ask.
And then, George, I see one here that I want to take because I have familiarity with other RASP solutions given my past life. So this question is, I have a mobile RASP solution already. Can Approve work with that? In short, yes, but let me extrapolate a little bit. I had mentioned traditional RASP, they either are embedded in the application through obfuscation and overlapping checksums, which is considered RASP because it prevents tampering, although it's quite static, that approach. And then there's other approaches that kind of combat active threats, often still deployed as an SDK. Approve has worked alongside solutions like that in a layered approach. Approve can also replace many of the functionalities that RASP solutions provide, like jailbreak, root detection, FRIDA, any kind of instrumentation framework. But the key difference here is that those solutions, they rely on-device response. So generally they crash the app. If they ever experience a false positive for an extended period of time, they're going to be crashing apps that shouldn't be crashing, and they can be difficult to update those security posture, those security making decisions on the device. Now, that being said, they do have a place. They work offline. They can help secure intellectual property, but they don't secure the API. People can attack APIs without even touching the app. So that's where, if you do need on-device RASP, you would also want a solution like Approve that can work as a layered approach to both verify the environment is secure and have a token approach to communicate with the backend, such that only authenticated versions of your mobile app can speak to your backend services. So that was a long-winded answer. I'm going to shut up now, but if anyone else has any questions, please do chime in, or if the answers we gave were too brief, shoot us an email, send me a LinkedIn message. We love having conversations with people as they're trying to tackle these problems live.
Yeah, and if you have a favorite application security solution you want to integrate with, just ping us and we'll tell you how to do it. So, Fortinet or Radware or whatever it is, we can certainly look at that for you. Okay. All right. Well, I think we've reached the end of the webinar. So thanks for attending.
Thank you, everyone. Thank you, George.
All right.
Thank you to the team at Approve who helped put this together, and I guess most importantly, thank you again to the attendees for being active.
Okay. Thanks a lot.